Welcome to example or exercise 3 in chapter 10. This is on your textbook page 10-13. So it's an isometric sketching exercise. And let's take a look at the SolidWorks that you have in front of you right now. That is the isometric 3D object that we're trying to sketch on the isometric graph paper that we're going to have. So let's just keep that in mind, and we can come back at the end of the exercise and check to see how well we did. So let's come on over to the textbook now, and as you can see, I have replaced the small little gridded graph paper from the book with the large gridded graph paper that your instructor can supply you. And if the instructor doesn't know where it is, tell him to see John Waddick. But it's in the physics storeroom in 7103 and 105. And this is nice graph paper to work with because it's much bigger and you can see features a lot better. All right, so let's get started. I have done some counting of the squares. The width I've done is 10 squares, the height is 4, and the depth is 3. So I've got the front view and then the top view. Alright, so let's first we would have drawn the bounding box, and I've already done that ahead of time because we've done this a few times, but what this bounding box, just to remind you, is the smallest rectangular box that would allow us to fit the object in. So what we end up doing is just making a rectangle with the maximum depth, width, and height of any feature on the part. Now we're going to do our cutting away. So I'm going to bring in my industrial eraser and be ready. So we have to decide, where are we going to start to cut? Alright, so let's start with the corner point right over in here. So these 2 points I'm going to call point 1 and point 2. Okay, so on my drawing over here, this is going to be point 1 and this is going to be point 2 right there. Alright. Now, what I see is if I go to the front, point 1 and point 2 are going to be right on top of each other. And if I go up 1, 2 squares, all of a sudden we start to cut away at a slant. So let me count 2 squares up from point 1, and I'll make a point. 2 squares up from point 2 and make a point. Now, once we get to this new point, which I guess I'll call point 3 and 4. Okay, so we'll call this point 3 and this point 4. All right, we now have to go to a point that's going to be basically point 5 and point 6, which is going to be right here. So let's point 5 and 6 are going to, in relation to point 3 and 4, are going to go up 2 and over 1, 2, 3. So up 2 and over 1, 2, 3. Okay, so let's call this point 5 and this point 6. All right, notice that point 4 and 6 are going to get connected together, and then 3 and 5. So this is where the object is getting cut. So I'm just rearranging myself because I like to draw with a backhand motion. And I'll just make a nice line right from 4 to 6, and then again from 3 to 5. And points 5 and 6, 5 is right here, 6 is right there. 5 and 6 are connected together. And we have our first slice, and also 3 and 4. 3 and 4, which are going to be right on top of here. These are going to be connected as well. So this point 1 has point 3 on top of it, point 2 has point 4 on top of it, and we're going to have another line that goes right here. Okay, so that's the first slice. So we can take that off. And now we erase. All right, that's the right side. Now let's do the exact same slice on the other side. All right, so what I'm going to do here is I'm going to create a dotted line. Okay. It's going to come down just so I can see this back corner. All right, so now that we have this, we know we're going to go up 2 squares, and then the analogous to points 5 and 6 are going to be up 2 and over 1, 2, 3. So here and here. Okay, so we're going to do a cut right from here to there, and then this cut we're going to see, and there's going to be a line across there. And as soon as we make that cut, we're going to see this, and then this is dotted for now. But once I take this top edge off of here, okay, now this edge is now going to be visible. Okay. So there are the 2 inclines. Now you'll notice the one on the left side here looks a lot smaller than the one on the right. Because think about it, we're looking at this 3D object from above and from the right. So we're looking more straight on to the plane 3, 4, 5, 6. Whereas this incline is actually inclining away from us. So we're not seeing as much of it. The biggest that a plane will ever be is when you look at it straight on with a line of sight that's 90 degrees to the surface. The further you get away from 90 degrees, the smaller a surface is going to appear. Now, if you don't understand what I'm saying here, is if I take this box right here and you look straight down, you see the full size of it. It's known as the true size, true shape. But if you look at this front side of the Ticonderoga box, as I turn it away from you, you see that it's starting to look smaller and smaller and smaller to the point it gets to be looking just as an edge. Okay, so this is a 90-degree line of sight into the surface, and this would be line of sight parallel to the surface. All right, enough on that. Just want to tell you why these 2 inclines are going to look smaller. One's going to look smaller than the other. Alrighty, we still have a little bit more work to do. Alright, it's going to be back in this region right in here. So we're going to take a square cutout, and as we go from point 1 or from point 2. Actually, that's not point 2 right there. That was because we're going to cut some more off. Point 2, I'm sorry, is actually going to be 1 square over. Okay, and point 4 is actually going to be right here. So what is this point over here? Absolutely nothing. Okay, so I've got from point 1 to 4. Now once I'm at 4, I'm going to be inclining up the slope. Alright, so now what I'm going to do is this inclined line right here, and I'll make another point, and I'll just call that point 7. Okay, point 7 is going to be up here someplace. I don't know where yet, but let me just draw. Well, I can figure it out probably. Point 7, which is going to be sitting right here. I know I have to go over 1, 2. So from point 2, I have to go over 2 squares, 1, 2. Then from the front view, I can see from point 2, I'm going to have to go up 1, 2, a little more than 3 squares. So 1, 2, a little more than 3 squares. Somewhere's up into there. And that doesn't make any sense to me yet because I have to be counting from point 2. I'm sorry. So we're going to go over 1. So from point 2 over 1, 2, and then over 1, and then up 1, 2, and 3, a little bit more than 3. So it doesn't come out exactly equal, but the point is this line that's coming up to meet it, this line and this line 3, 5 have to be about parallel to one another, okay? So I'll just erase it. I'll try to make it as parallel as I can. Okay, so this point is going to be point 7. 7 is then going to go to a point 8, which is going to be over on this surface here, and I get this. From point 8, I'm going to come straight down, and this point is going to be over 2 squares. So my lines aren't exactly right. It's supposed to be over to there, but that's pretty close. Okay, so now I can erase all of this, and I'm going to just fill in this line because 2 and 4 are going to be connected, and this is going to go back to this point. This is going to come down to here. This is coming into here. So I can see that I probably have to move point 3 just a little bit, okay? So I should have just had it come right to this point, right to here, and just made this something like that. So, okay. And then point 3 is coming over. Okay, so exactness is not really the name of the game in isometric sketching. It's to be able to somehow convey a general idea. Nobody should be taking any scaled measurements off of your isometric view. Alright, so that's what the cutout on the right side is. If you looked at it from above, you'd see this L shaped. Now you're saying, well, it doesn't look, this part of the L up here in 5, 6, actually 8, 6, 5, and 7. This area up here seems thicker than you see it over here, and it's because we're looking more straight on in the isometric than we are here. So as we look more at a straight line of sight of 90 degrees, the objects are going to look bigger. Alright, so I've got a line here. Alright, now what we have to do is make the same cutout on the back surface. And because we're starting to work in an area where we don't have visibility, it's going to be a little bit harder. Alright? But let's start out with something. Okay, just like we had a point 2 over here that was 1 square in toward the front from the back. Let's start with this point here, and I'm going to go to here. So now I've got the analogous of point 2. Okay? Now from point 2, we're going to come up this way. We're not sure how far yet, but we're going to come up to there. Now right now all of this is not visible. Okay. Now once I come up to there, I have to, now point 4 was 2 squares up, so 1, 2. So I'm going to go right up to there. And now I've got to make a line that's parallel to this line right here. The other thing I can do is know that I'm going to be 1 square in from this back. Let's see. So let's see. When I bring this in, I'm going to be, now my gut tells me that it should look like this, but that's not right. So actually I'm going to go over 1 square, so it's actually going to look like that. Alright. So notice how we have this part, that's kind of this part over here. Alright, now this cutout over here, from this front corner we came in 2 squares, 1, 2, and then we went back 2 squares. Alright. Now, if the object starts flipping on you, just look away and then look back at the object, because sometimes it flips and then your mind starts playing games with you. All right, so we're going to cut this away. So we're going to cut back just like we did here, and then we're going to come over, whoops, over here. Now this is still going to be hidden, but we're going to cut that shape out right there. Now this is going to come straight up here, and it's eventually going to intersect with that point right there. Okay, so like this line comes up to here, we have the line on the left side doing the same thing. The analogy to point 7 is right there. Okay, now we're going to come over to point 8. This line is going to come this way. And let's see, it's point 8 was over 2 and up about 1, 2, 3 and a little more. So over 2 and then up 1, 2, 3 and a little more. The thing is flipping on me again. I'm looking away. Okay. Well, I know that it's this line up here is going to have to be somewhat parallel like this. Okay, just like 7, 8 is parallel to 5, 6. This is going to have to be parallel. So, from this point right here, I come in. This point 8 is going to be 1, 2, 3, 3 and a little more. 1, 2, 3, and I guess a little bit more. So I'll draw that to here. Okay. Now I've cut this much away, so I'm going to take all this away. I'm going to take this away. I might see that again, but okay. Now this cut that's going in here, I'm actually not going to see right in here. So that's actually hidden. So that's going to be a hidden feature. I'll erase that in just a bit. But I'm going to see this. I'm going to see this. There's not going to be a line there. So this back side, and I'll just erase all the hidden lines now because those are going to get confusing to us. And like I said, the back side's more, this left side's harder to do because we're dealing on a face that's really not very visible. But that is the left and right of this. The inclined surface on the right, because we're looking more straight on, looks bigger. This one over here on the other side really looks a lot smaller because it's we have a line of sight that's getting almost parallel to that surface. Alright, so not too bad from there. Last thing here on this drawing is going to be doing the circle, which is from this, this point 8. It would be over 1, 2, 3 squares. Okay, where this point line is, it's over 1, 2, 3 squares and up 2, 1, 2. Now here we put a line, a center point, in the plane of the front. And then this circle has a radius of 1. So in each of these principal directions of the center mark, we make a dot. We know our circle is going to have to go through each of those dots. And now we're just going to make a square in this plane. Okay, so it's going to look like this, and for some reason this shape just keeps flipping on me. And what I mean by flipping is I start seeing it upside down or inside out, and that's going to happen. If that happens, just look away somewhere, look at something else for a second, then come back to it and your mind will reset. Alright, so now we have to do tangent to tangent. Down here, tangent to tangent. And I like to do this all going with backhands. Tangent to tangent. And when you come in tangent, you really want to come in like almost parallel to the line. So now we can just erase the square. One check to see if the circle on the back side show any shape in here. It probably won't because it's pretty thick. 1, 2, 3. So if I did a circle back here, no, we're not going to see any of that circle, so I'll just erase that. Okay, so I believe we are pretty good. Now let's go over to the SolidWorks and see what that looks like. And you can see that, notice we see a little bit of this shape here, and we actually didn't do too badly. All right, so that is the third and final isometric exercise that I'm going to go over. So for homework, you're most likely going to do exercises 4 through 10.